What material would you recommend for joint filling in industrial floors?
We recommend using semi-rigid products, semi-rigid epoxy or semi-rigid polyurea products because they provide load transfer and joint edge protection to protect the top shoulders for small wheel impact. There are two primary products used for joint sealants and fillers, semi-rigid products as well as elastomeric sealants. For industrial floors with small wheel traffic, we always recommend using the semi-rigid, either polyurea or epoxy, because they provide joint edge protection to prevent spalling.
Why would you use a semi-rigid rather than an elastomeric in industrial floors?
Elastomeric sealants are designed to expand and contract to accommodate movement in a joint to provide a seal so moisture can't penetrate. Um, the semi-rigid products are designed for hard wheel traffic to provide joint edge protection and prevent spalling. So the elastomeric in an industrial application would not provide that type of joint protection from spalling.
Why would you use a semi-rigid rather than an elastomeric in industrial floors?
The ACI recommendations in the ACI 302 and 360 documents specify a semi-rigid joint filler for trafficked floors. The reason why we don't use elastomeric is because they're designed to provide movement and to seal a joint, but they're not designed with the type of Shore hardness to provide edge protection and prevent spalling.
When should joints be filled in new constructions?
The ACI documents 302 and 360 indicate that joint filling should not be performed prior to 30 days after slab placement. Our recommendation as well is to defer 60 to 90 days. The goal is to provide as much early concrete shrinkage as possible so that the joint can contract and widen prior to joint filling. If the filler is installed too early after concrete placement, joint filler separation will occur where the filler will actually tear within the joint.
What are the proper considerations for a proper joint filling?
Proper joint filling consists of four primary components. The first component is selecting the appropriate material for the given traffic or application. Semi-rigid joint fillers, but the correct semi-rigid joint fillers for the specific traffic. The second component would be joint preparation to ensure performance and adhesion. The joints must be cleaned to the proper depth, which in a traffic floor would be the full contraction joint depth, to expose clean concrete joint sidewalls. The third component is proper installation of the material to achieve the proper cure. There's various methods to install joint fillers, but the key is that the material cures properly. And the final component then would be to finish the joint filler flush to the slab surface. It's critical that the finished profile be smooth and create a smooth transition across the surface of the slab to provide joint edge protection.